Hi dears, in this video we are going to discuss the top 30 questions from the chapter chemical bonding. It will be most helpful for your upcoming NEET examination. So we are going to discuss the 30 questions and the detailed solutions. Are you ready to watch it? So let's start. Guys, this is the first question. This is the first question. Which of the following pairs of ions are isoelectronic and isostructural? Here they given different species. They are asking isoelectronic and isostructural. We can take one by one. So the concept we can look at, we are going to check is whether the compound have isoelectronic means same number of electrons as well as isostructural. Okay. So for that we are taking the first one, option A. In option A, ClO3 minus. Okay, ClO3 minus. So first of all, we are going to find out the total number of valence electrons. See, total number of valence electron. Okay, in chlorine, atomic number is 17. So electronic configuration is 287. So valence electron is 7. Plus oxygen, atomic number is 8. So 2, 6. Valence electron is 6. So like that, 3 oxygens are there, 3 into 6. And here minus 1 means 1 electron they gained. So plus 1. If it is plus means we will subtract. That's it. Okay. So here 7 plus 3 into 16. That means 18 plus 1. Total 26 valence electrons are there. Okay. How many valence electrons are there? 26 valence electrons are there. That only we are going to check it. If total number of valence electrons are same means then they should be isoelectronic as well as they should be what? Isostructural. That's the idea we have to remember. Next I am going to check for CO3 2 minus. In CO3 2 minus, carbon atomic number is 6. Electronic configuration 2, 4. So valence electron is 4 plus oxygen atomic number is 6. So atomic number is 8. So valence electron is 6. 3 into 6. And minus 1, minus 2 means 2 electron we have to add. So total 4 plus 18 plus 2, that means it is 24. 24. Their valence electrons are not same. Automatically they are not isoelectronic, they are not isostructural. We can check the next one. Here SO3 2 minus is there. SO3 2 minus is there. What about SO3 2 minus? Sulfur valence electron, atomic number is 16, or 16th group, 6 valence electron. So 6, oxygen also 6 valence electron. So 3 into 6, like that 3 oxygens are there. And 2 minus means 2 electron they are gaining. Plus 2 you have to add. So once you are adding 6 plus 3 into 6, 18 plus 2, that means 24 plus 2, 26. Yes, this also contains 26 valence electron. This also contains 26 valence electron. So ClO3 minus and SO3 2 minus both have same shape and same isoelectronic also. So option C is the correct answer. ClO3 minus and SO3 2 minus have same number of valence electron. You can check for the remaining also. Okay, what? That NO3 minus, that and all also you can check it. Idea clear? Ready? So here ClO3 minus, SO3 2 minus, ClO3 minus, SO3 2 minus. 2 options are there. 2 are correct. C and D are correct. Okay. Yeah. We can go to the next question. This is the next question. What about the question here? The correct bond order in the following species is. This is a question related to molecular orbital theory. In any examination, repeatedly they are asking this question. Bond order and bond stability, bond length, that related question from molecular orbital theory. First of all, if they are giving this kind of question, what you want to do now, you have to find out the total number of electrons in each species. First one, O2 2 plus. O2 2 plus means in oxygen molecule 16 electron and 2 plus means 14 electrons are there. In O2 minus oxygen 16 electron, O2 minus means 17 electrons are there. In O2 plus, total how many electrons are there? O2 means 16, O2 plus means 15 electron. Now if you know the number of electron, then you must have to know the bond order. For that, let me show you one idea. This is the idea you have to remember. This is the idea you have to remember. Just look at here. It's easy. See, it's easy. This is the idea. The maximum bond order is shown by 14 electrons. 14 electron, I mean in nitrogen is the maximum bond order, N2. That means 14 electrons comes means bond order is 3. Then 15 comes means 2.5. 0.5 you can reduce. 16 comes means 2. Okay. 17 comes means 1.5. Then again 18 comes means 1. Like that. Here also same. 13 comes means 2.5. Okay, 13 comes means 2.5. 12 comes means 2. Okay, then 11 comes means 1.5. 10 comes means 1. Like that you can assume. So now in our question, what they are telling. So in the case of, see, in the case of O2 2 plus 14 electrons are there. So bond order is 3. Bond order is 3. In the case of O2 plus 15 electrons are there. 1 electron extra, that means its bond order is 2.5. And in the case of O2 minus 17 electrons are there. If it is 17 electron means bond order is 1.5. Bond order is 1.5. Okay, 1.5. So which is having more bond order? More bond order for O2, O2 2 plus. Then bond order is O2 plus. Okay, O2 plus. Then which one is coming? O2 minus is coming. Idea is okay. O2 2 plus. Then O2 plus. Then O2 minus is coming. The same only the bond order as well as bond stability, bond strength, all in same order. So you have to remember bond order is directly proportional to bond stability. Okay, bond stability, bond energy. Okay, bond energy and inversely proportional to bond length. This much idea if you remember means you can easily answer the question from here. Is it okay guys? Okay, so we can move to the next question. This is the next question. What's the question here? Maximum bond angle at nitrogen is present in which of the following? So bond angle depends on the number of lone pair electron. If more the number of lone pair electron means bond pairs will come closer. 0 lone pairs means they can arrange maximum away from each other. This is the minimal concept we have to remember. Now I am going to find out the bond pairs and lone pairs. See, NO2 minus if I am taking, NO2 minus means in nitrogen how many valence electrons are there? If we are finding bond pair, lone pair, that time we have to use the what? We have to use the valence electron. In nitrogen, how many valence electrons are there? 5. In oxygen, how many valence electrons are there? 6. 6 into 2. 2 oxygen are there. And minus 1. That means we have to add 1. So 5 plus 12 plus 1. So total how many are there? Total is 18 valence electrons are there. Is it okay? You know how to find out the total valence electron. Then what you want to do? You have to divide this 18 with 8. With 8 you do. You have to divide it. That time 2 8s are 16. Remainder is 2. This much okay? Ready? Now see the magic. Here what will be the answer you are going to get? That represent the number of bond pairs. Number of bond pairs. And 2, the remainder that represent, that you have to convert it into pair. 2 electron means 1 pair, that is 1 lone pair. Now I have got bond pair equal to 2, lone pair equal to 1. So bond pair equal to 2, lone pair equal to 1 means inverted V shape. Inverted V shape. This is the format. This is the format. Okay, this is the format. Because of lone pair, that bond angle will be less than 120 degree. That idea you must have to know. Okay. Then what about NO2 plus? NO2 plus, how I can calculate? In the case of NO2 plus, nitrogen valence electron is 5. Oxygen is 2 into 6. Plus means 1 electron is missing. We can remove 1 electron. So 5 plus 2 into 6 means 12. Minus 1 means 16 will come. 16 divided by 8 if I am doing, that means 2 8s are 16, remainder is 0. 2 bond pair, 0 lone pair. That will be the answer. Why? 2 bond pair, 0 lone pair means its shape will be linear, AB2 type. So bond angle is 180 degree. So our answer is what? Option B. You can check the remaining also. Here, in the case of NO2, 1 odd electron will be there. Because of odd electron, their bond angle will reduce. Here, NO3 minus, no bond, no lone pair. But in the case of NO3 minus, once you are doing, that also you can check it, okay. NO3 minus, once you are doing, nitrogen valence electron is 5, oxygen is 6, like that 3 are there. Minus 1 means I have to add 1. So 18 plus 5, 23 plus 1, 24. But if I am dividing 24 with 8, 3 8s are 24, remainder is what? Remainder is 0. 3 bond pair, 0 lone pair means it is AB3 type. AB3 type. Here bond angle is 120 degree. So our answer is what? NO2 plus, that is 180 degree, because they are asking which of the following has maximum bond angle. Idea clear, guys? Ready? Yes, we got it. Okay, we got it. Next one, next question. Once we are going to the next question, again the question is the hybridization of the atomic orbitals greater than NO2 plus, NO3 minus and NH4 plus. The same thing we can do it. Now only we did it NO2 plus. You just find the number of bond pairs and lone pairs that we did, that we already did. Greater than valence electron is 5. Okay, oxygen it is 6. 6 into 2. Because 2 oxygens are there. Plus means 1 electron is missing. Minus 1. So total 16. What do you want to do? You have to divide 16 divided by 8. So 2 8s are 16. Okay. Remainder is 0. So here 2 bond pair, 0 lone pair. 2 bond pair, 0 lone pair. You are adding, you will get VSCP. VSCP 2 plus 0 means 2. VSCP 2 means hybridization is SP. What's hybridization? In NO2 plus, hybridization is SP. You can check it. 2 options are there. 2 options are there. NO2 plus is SP. And what about NO3 minus? That also we already find out. NO3 minus. Okay, NO3 minus means what? Nitrogen valence electron is 5. Oxygen valence electron is what? 6 into 3. 6 into 3 minus 1 means we are adding one more electron. So 5 plus 6 into 3 means 18 plus 1, that means 24. 24 divided by 8 once you are doing, you will get 3 8s are 24. Remainder is 0. The answer you are getting is bond pair. This one is lone pair. 0 means no need to make it pair. 0 lone pair. 3 bond pair, 0 lone pair. Once you are adding, VSCP equal to 3. VSCP equal to 3 means sp2 hybridization. So the first one is sp, second one is what? sp2. So answer is what? C. How you will do for NH4 plus? That also we can do it. How we can do it? See how we can do it. NH4 plus means here NH4 plus. We can do it in many way. NH3 you remember, it is pyramidal shape. See NH3 we are learning. One lone pair is there. This lone pair they are donating to that incoming H, then only they are forming what? NH4 plus. Like this only NH4 plus. Okay, so here it is tetrahedral. Around it 4 bond pairs are there. So that's why it is sp3. So what's the option for our question? You can see our answer is what? C. Ready? Yeah, I hope you are getting all the ideas. Easy, easy. We can go to the next question. What's the question here? In the structure ClF3. It's the interhalogen compounds. Okay, the number of lone pairs of electrons on central atom chlorine is. We can use our formula. What technique I taught you? ClF3 means what you want to find out. You have to find out the total number of valence electron. So in chlorine valence electron is 7. Fluorine also same group. So same number of valence electron. 3 into 7. So 21 plus 7, 28. 28 divided by what you have to do? 28 by 8. That means 3 8s are 24. Remainder is 4. Don't forget the answer you are getting is bond pair. Okay, 3 bond pair. Here you are getting the remainder that you have to make it into pair. Don't take it as a 4 lone pair. Wrong. Wrong. But what you have to take it as? You have to take it as what? That 4 means that is remainder that you have to make it as a pair. That will be 2 lone pair. So what's the answer for us? So here the structure around chlorine central atom. How many lone pairs are there? 2 lone pairs are there. If they are asking what's the hybridization, how I will do? I know 3 bond pair, 2 lone pair. So that is bend T shape. That is bend T shape or else T shape. Okay. What's the hybridization? 3 plus 2 means that is VSCP. Valential electron pair is 5. Bond pair plus lone pair. Bond pair plus lone pair, that is VSCP. That's equal to 5. 5 means what's hybridization? sp3d. That's it. And because of lone pair, what shape they will arrange? Bend T shape. What's the geometry we are expecting? Trigonal bipyramidal. This many information we are getting from this idea. Total valence electron by 8. That formula you keep it in mind. Okay guys? Yes. We can go to the next question. What's the question here? Which of the following is paramagnetic? Which of the following is paramagnetic? You have to remember, if the number of electrons is odd, then that will be paramagnetic. Plus 10 and 16 electrons comes in a molecule, that also paramagnetic. So which all are paramagnetic? Remember, paramagnetic means all odd electron containing molecules, okay, containing molecules, all odd electron containing molecules, plus 10 and 16 electron, 10 and 16 containing electrons also paramagnetic. What about diamagnetic? All are paired. All are paired means even number electron containing species. Even number electron containing species except 10 and 16. 10 and 16. 10 and 16 comes here, that is paramagnetic. What about nitrogen? Nitrogen means 14 electron, even diamagnetic. H2 means 2 electron, even diamagnetic. Li2 means lithium means 3, Li2 means 6 electron, even number diamagnetic. O2 means 16 electron. This one molecular orbital theory, not total valence electron, total electron. Valence bond theory, total valence electron. Valence bond theory, total valence electron. Here molecular orbital theory, total electron. Don't forget. Okay. Yes. So here oxygen, total 16 electron. 16 is the even though it is what? Paramagnetic. So our answer is D. No need to solve it. No need to write sigma 1s2 sigma star 1s2 sigma star 2s2. No need. Okay guys, ready? Yeah, we got it. We can go to the next question. What's the question here? This is a previous NEET question. The number of hydrogen bonded water molecules associated with the copper sulfate dot 5H2O is. See, the structure of copper sulfate dot 5H2O is Cu, okay, H2O 4 times, okay, 4 times SO4 dot H2O. This is actually the copper sulfate 5H2O. Here, this copper is the central atom, H2O is the ligand, SO4 is the counter ion, this H2O is the hydrogen bonded one. That means, see, around copper 2 plus is the central metal atom. To that, your H2O, how many H2O? 4 H2O, they are donating lone pair. H2O is donating lone pair with the coordinate bond. 4 H2O are there. They are donating electron pairs to the central metal atom. With this Cu2 plus, just nearer to that, SO4 2 minus will be there. They are forming what? They are forming ionic bond. And one H2O will be, this one I am showing, this OH2 I am showing, you can see here this OHH. And one H2O will be, one more H2O is there. That H2O is forming what? That H2O is forming intermolecular hydrogen bond with the coordinate bonded water molecule. So how many water molecules are forming associated with the hydrogen bond? 1. How many are associated with the coordinate bond? 4. Don't forget, okay? Keep the idea. So see, next question, we can move to the next question. What's the question here? Identify the incorrect statement related to PCl5 from the following. Whenever they are talking about PCl5, we know the structure of PCl5. P, Cl, Cl, Cl. These 3 Cl bonds are in, PCl bonds are in same plane, and one Cl is projecting out. And one Cl is projecting in. That is, I am drawing like this. That white color I am representing, that is axial bond. Okay. This yellow color is what? Equatorial bond. What bond? Equatorial bond. This yellow color is equatorial bond. This also equatorial. This also equatorial. Ready? This much idea I know. And one more idea we know. Length of axial is greater than length of equatorial. That also we know. Now we can check about the question. What about the question from the following? Which is the incorrect statement. They are asking about the incorrect statement. What about the first statement? 3 equatorial PCl bonds make an angle 120 degree with each other. Yes, of course. They are making 120 degree. This one 120 degree, this one 120, because that triangle is in the same plane. 120, 120. That's correct. 2 axial PCl bonds make an angle 180 degree with each other. Yes. This Cl is projecting out. This Cl is projecting in. They are actually like this, okay. They are actually laying like this in a plane. Here only that 3 PCl bond will be there in this plane. Okay. So that is also correct. Axial PCl bonds are longer than equatorial PCl bonds. That I already wrote. What about the next one? PCl molecule is non-reactive. That is wrong. Because this length of axial is more than this one means once we are heating this one, what will happen? The more bond length means easy to break it. This will break. That will be becoming what? PCl3 plus Cl2. So PCl5 is the reactive molecule, not non-reactive molecule. Ready? Yeah. So our answer is what? D. Incorrect statement is D. Yes. We can move to the DAs. I hope you are getting the ideas. Okay, you are spending a lot of time to watch this video, I know, but it should be beneficiary. I'm damn sure about that. It is beneficiary. Be with me. We are going to crack it. Okay. Yes. See, what about the question number 9? Here the question is AsF5 molecule is trigonal bipyramidal. Trigonal bipyramidal means its hybridization is sp3d. Okay. The hybrid orbitals used by the As atoms for bonding are. In sp3d means s orbital should be only one orbital is there. That is non-directional s. P means they are directional px, py, pz. D means 5 orbitals are there. Out of that, which one we will take for sp3d? dz square, because z axis is the main axis we are considering. Okay. In the case of sp3, d2 means dz square and dx square minus y square. That idea you have to keep it in mind. So our answer is what? S, px, py, pz, dz square. Don't forget. Okay. Don't forget the idea. Next one. Again, next question. What about the question? The shapes of SF4 and XCF2 respectively. You can do it in many ways. We can do with our idea. This shape means valence bond theory. I mean VSCPR theory and valence bond theory both contain V. So that means valence electron we have to take. What about SF4? SF4 means sulfur. Sulfur valence electron 6. Fluorine valence electron 7. Okay, 7 into 4. So 6 plus 7 into 4 means, that is 7 into 4 means 28. So total 34 valence electrons are there. 34 divided by what? 34 divided by 8 once you are doing, you will get 4 8s are 32, remainder is 2. 4 bond pair. Okay, the answer you are getting is bond pair. Here it is bond pair. This one you have to make it as what? This one you have to make it as pair. 2 means 1 lone pair. 4 bond pair, 1 lone pair means its shape is seesaw. Its shape is what shape? Seesaw shape. So first one is seesaw shape. And XCF2, only one answer, only there B. Or else we can remember XCF2 also we can try to solve it. XC means total. XC belongs to 18th group. So valence electron is how many? How many valence electron? 8 valence electron. Plus fluorine valence electron 7. 7 into 2. So 2 into 7 means 14. 14 plus 8, 22. 22 divided by 8. 22 divided by 8. Meaning 2 8s are 16. Remainder is 6. This answer is bond pair. This one we have to make it as pair. 3 lone pair. So 2 bond pair, 3 lone pair means its shape is linear. What's the shape? Linear shape. So it will be like this. XC will be there. Here fluorine. 3 lone pairs will be there. What's the hybridization? I can add it. Total is 5. 5 means sp3d. So many ideas we can tell, dears. So many ideas we can tell. Okay. Yeah. So what's the answer for our question? Our answer is B. Ready? Yeah. We can move to the next question. What about the next question here? In piperidine, they given piperidine molecule. You can see this is the piperidine molecule. This is the piperidine molecule. N, here H. Okay. This is the piperidine molecule. The hybridization of nitrogen atom is. If you want to find out the hybridization, we must have to know how many bond pair, how many lone pair. That's an easy method. So see, in nitrogen they are asking, this is the nitrogen, around nitrogen, this is one bond pair, this another bond pair, this another bond pair. So how many bond pairs are there? 3. And along with that, in nitrogen, one lone pair also there, lone pair. That they won't represent, then you know to be represent. You have to remember, nitrogen 3 electrons are there, 2 more electrons are there around nitrogen. So that means lone pair equal to 1. Total VSCP how many? VSCP 3 plus 1 is equal to 4. 4 means which hybridization? sp3. 1s and 3p. Okay, so that means sp3 hybridization. Answer is what? C. Ready? Yes. We can move to the next question. What's the question here? Ratio of hybrid and pure orbitals in benzene. So to tell about this one, we must have to know the structure of benzene. This is the structure of benzene. Listen to me very carefully. Listen to me very carefully. This is the structure of benzene. Okay, this is the structure of benzene. See, this is the structure of benzene. Okay, here everywhere what is there? Along with the carbon, hydrogen is there. Along with the carbon, hydrogen is there. Okay, here also hydrogen is there. Here also hydrogen is there. Here also hydrogen is there. Now see, listen to me very carefully, guys. Listen to me very carefully. Here, each carbon is in sp2 hybridization. That means this carbon is in sp2 hybridization means how many sp2 at a time they will produce? sp2 means 1s and 2p you are mixing. That means 3 sp2 at a time they will produce. So this carbon will produce 3 sp2. One here, one here, one here. 3 will be there. This carbon also will produce 3. So each carbon can produce how many sp2? 3 sp2 they will produce. This will produce 3. Okay, each carbon will produce 3 sp2. See, each carbon will produce 3 sp2. They will overlap like this. So 6 carbon are there. So 6 into 3. That means 18 sp2 hybrid orbitals will be there. Ready? And each carbon, sp2 means in each carbon, 1p will be there. 1p will be there as without mixing for hybridization, without using for hybridization. So 1p will be there here. Here 1p will be there. Here 1p will be there. Here 1p will be there. Here 1p. Here 1p. This pp only they are forming pi bond. So how many p orbitals are there? How many pure p orbitals are there? Pure p orbital is equal to 6. Similarly, this hydrogen is coming to overlap with sp2. That means like that how many hydrogen 1s orbitals are there? 6. 6 1s orbitals are there. So pure s orbital is equal to that also 6. So total pure orbital equal to 6 plus 6 12. Here 18 hybridized orbital. So what's the ratio? What's the ratio? See, what's the ratio? Hybrid orbital is to hybrid orbital equal to hybrid orbitals is equal to what? Hybrid orbitals is equal to 18. Pure orbitals is equal to what? Pure orbitals is equal to 12. 12. So 18 is to 12. 3 is to 2. Option A is the correct answer. You have to remember here ratio of hybrid and pure orbital in benzene which is participated in bonding. That's the best question. Because other than not participating in bonding, inner orbitals are so many are there in carbon and all. We have to calculate only bonding. That means that's the ratio 3 is to 2. Ready? Yes. Fine. We can go to the next question. What about the question here? They given the dipole moment of chlorobenzene is 1.5 D. Then the dipole moment of this one is a repeatedly asking question. What about the idea here? You can see, it's easy. Very easy idea. Here you can see, this is chlorobenzene. In chlorobenzene, the polar bond is this one, carbon-chlorine bond. This one only, its dipole moment, they given 1.5 D. Okay, this is 1.5 D. So see, they are asking about this one. I am drawing that one here. You can see, I am drawing that one here. You can see, this is the one. Okay, here benzene, here chlorine. Okay, here chlorine and here chlorine as well as here chlorine. Am I correct, right? See, yeah. Here ortho portion, meta portion and here also meta portion is there. So see this one. Here once you are looking, which all are the bonds are polar. This carbon chlorine is polar. Chlorine will take the electron towards it. Dipole moment will be in this direction. This carbon chlorine will be polar. That will take the electron towards it. That will be in chlorine direction. Dipole moment. Here in towards this chlorine direction. Here this towards this chlorine direction. Here one problem is there. What's the problem? What's the idea? What's the easiness? This one will get cancelled. Why? Because both are equal and opposite vectors. So that's why they will get cancelled. What about this one and this one? That is at an angle of 120 degree. 120 degree. If it is x, this also x. Both are x. Their direction only changing. Then this is, you can call it this. You can call this the x. This one also x. Their angle is 120 degree. Then mu resultant equal to, if it is 120 means resultant will be same, x only. We can check it, okay. Root of x square plus, okay, x square plus 2 into x, 2ab cos theta. Cos theta means minus 1 by 2. Cos 120 means minus 1 by 2. 2 will get cancelled. Root of 2x square minus x square equal to what? Root of x square equal to x. So mu resultant also x. So 120 degree two vectors comes means its answer will be similar to the first vector. Two vectors are equal and they are actually in an angle of 120 degree means their resultant will be similar to any one of the above. Any one of the given. So here that x only answer. This one 120 degree only. So their answer is Chlorobenzene's value only, that is how much? 1.5 d by, so option C is the correct answer. Ready? Clear? Okay. What a simple questions, okay. If you can remember, if you can use your logic, you can easily answer it, guys. Okay, guys? Ready? See. Next one. Give the decreasing order of thermal stability of the following. They actually given, see, once you are looking the carbonates of alkaline earth metals. What about alkaline earth metals? Beryllium, magnesium, calcium, strontium, barium. Out of the strontium they didn't given, they mention only this one. Once we are going downside, okay, you can see this all is forming what? Beryllium 2 plus, magnesium 2 plus, calcium 2 plus, barium 2 plus. Once we are going downside, the atomic size is increasing, but the charge remains same. Charge is 2 plus only. That means their charge density decreases while we are going down. Charge density decreases while we are going down. Why? Because size is increasing, but only 2 charge. 2 charges distributed in small size, 2 charges distributed in large size, means here charge density will be less, because 2 charge, only 2 plus charge that is distributed in a large volume means density will be less. Here density will be more, because 2 charge we are distributed in a small size, okay, that means charge density is more on the top. Once we are going downside, charge density is less, means along with that which group is there? CO3 2 minus is the anion. So whenever they are going nearer to that anion, whenever this cation is going nearer to that anion, charge density more means more distortion capacity for cation. Charge density less means less distortion capacity for the cation. That means charge density less means less distortion capacity, less distortion in anion. Less distortion in anion means they are stable. So that means barium 2 plus and CO3 2 minus, they are stable. We cannot break it easily. So barium carbonate is more stable than calcium carbonate, than magnesium carbonate, than beryllium carbonate. In the case of beryllium carbonate, charge density is more. So that will distort more that CO3 2 minus anion, electrons in anion. So that means easily breakable. That bond is not powerful. That's the meaning. Okay, yeah. So B is the answer. Next one. What about the next question here? Among lithium chloride, beryllium chloride, boron trichloride, carbon tetrachloride, covalent bond character. You can do this one in many ways. Either you can use what? Fajan's rule. What about Fajan's rule? See, lithium chloride, beryllium chloride, boron trichloride and CCl4. You can use the Fajan's rule. Here anions are same. Cl minus, Cl minus, Cl minus, Cl minus. Okay, but cation, here it is plus 1, here it is 2 plus, here it is 3 plus, here it is what? Carbon means plus 4. So you learn the idea, charge on cation or anion is increasing, covalent character is increasing. So it is more covalent than this one, So CCl4 is more covalent than BCl3, than BaCl2, than LiCl. That's the idea, simply you can answer it. Or else, you can use the logic. What? Chlorine is in 17th group. Carbon 14th group, boron 13th group, okay, beryllium 2nd group, lithium 1st group. If the atoms they are going to make a bond, if they are coming closer means electronegativity difference less electronegativity difference, automatically they will form what? Covalent bond. If the difference between if the distance between the atoms are more, one is in 1st group, one is in 17th group. The difference is more, distance is more. So electronegativity difference is more means they are ionic in nature. They're compared to other one, ionic in nature. Like that also you can answer it. You can use your what? Logic, common sense in many questions in chemical bonding, because you learned all the questions. I'm damn sure about that. You are preparing for this year NEET examination. So automatically, you know the basic idea from chemical bonding. A lot of basic idea you are learning that you already applied in different chapters, right? Yeah. So it will be useful. Okay? Yes, guys. Yeah. We can go to the next one. What about the question here? Which of the following species have a double bond is made up of only 2 pi bonds? This according to molecular orbital theory. According to valence bond theory, as well as according to VSCP, according to valence bond theory, what we learned? We learned the idea only after sigma bond formation only pi bond will form. But in molecular orbital theory, it is not like that. That idea you have to keep it in mind. Okay, yeah. See, here here the answer is what? C2. Why? In C2, total electron is 12 electron. Total electron is 12 electron. You write the electronic configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, okay, pi 2px2 equal to pi 2py2. So 12 electron means according to our that pyramid idea. I taught you one pyramid idea. You remember 14 means bond order is 3, 13 means 2.5, 12 means 2. So 12 means 2 is the bond order. 2 is the bond order. That means 2 bond order means carbon double bond is there. Out of that, which one bond means 2 electron. So this 2 electron is pi. This 2 electron also pi. So last electrons are in pi orbital. So that's why 2 bonds are pi. What about the case of oxygen? It's not like that. One is sigma, one is pi. Okay, you can check it. Remaining all you can check it. In the case of carbon only, these 2 are pi. Is it okay? Yeah. We can move to the next question, guys. What about the question here? In PO4 3-, the formal charge on each oxygen atom and PO bond order are respectively. We can, if you remember the structure of PO4 3- is very easy. Or else you can do like this. Phosphorus is there. Around it, how many oxygen? 4 oxygen. 1, 2, 3, 4. Tetrahedral only the structure. And what we will do? In oxygen, around it, around it, they should have to make 1 bonds. Okay, 1 bonds. Okay. So, or else we can start like this. Like this. What? Oxygen here 2, 4, 6 is there. Okay, here also 2, 4, 6 is there. 2, 4, 6 is there. 2, 4, 6 is there. Fine. Yeah. Once we are calculating this one, you can see around it 5 electrons are there. 2, 4, 5 electrons are there. And this oxygen should have to get how many electrons? It should have to get 2 more electrons to get stability. So this oxygen and this phosphorus, they will make a double bond first. Okay, double bond first. Now 3 electrons are there, 3 oxygens are there. So what it will do? It will make a single bond with this one. Okay, it will make a single bond with this one. It will make a single bond with this one. For that, they will use one electron from each oxygen. Here 1 electron will be there. Here 1 electron will be there. Here 1 electron. But they have to get octet means 1 more electron we have to add it. That means minus. 1 more electron I have to add it minus. 1 more electron I have to add it minus. That's the idea. This is the structure of PO4 3-. Here you can see what's their formal charge. Formal charge. They are asking about formal charge. Formal charge means because of resonance, this minus can come here, this minus can come here, like that. That shifting is possible. So formal charge, while we are calculating, we will take the average. -1, -1, -1. Total how many are there? -3. -3 are there. How many oxygens are there? Total 4. So -3 by 4. That means -0.75 is the formal charge. How many options are there? 3 options are there. What about the bond order? Bond order between PO bond, that is equal to bond order between PO bond means 1 plus number of pi bonds. How many pi bonds are here? 1 divided by how many sigma bonds are there? 1, 2, 3. 1 plus 1 by 3. Okay, not 3, 1, 2, 3, 4. Total 4 are there. 1 plus 1 by 4. That means 1.25. So which option will be coming? Option B is the correct answer. How easy is? Yeah. Then you have to check for the CO3 2-. Okay, don't forget. You have to comment the answer in the comment box. Okay, don't forget about it. What about the next one? KF combines with HF. KF means K plus and F minus. HF means HF. This is the HF. So here this F minus can go and form hydrogen bond with HF. This can go and form what bond with HF? Hydrogen bond with HF. Because fluorine is highly electronegative and K plus. So this will be coming together. That is what is HF2 minus. HF2 minus and K plus they will form. The compound contains the species K plus and HF2 minus. Option C is the correct answer. You got the idea? Yeah, simple one. What about the next one? In the reaction 2PCl5. You can see 2PCl5 become PCl4 plus PCl6 minus. You know, they are asking the change in hybridization from. We know the basic idea, the hybridization of PCl5 is sp3d. sp3d, because we drawn the structure of PCl5 already. Around phosphorus 5 bond pairs are there, 0 lone pair, so sp3d. What about PCl4 plus? You can check it. Phosphorus valence electron is 5. Chlorine valence electron is 4 into 7. And plus means 1 electron is missing. So 4 into 7, 28. 28 plus 5, 33. Minus 1 means 32. Okay, minus 1 means 32. Okay, so 5 plus 4 into 7. So 32 valence electrons are there. 32 divided by 8 means 4 8s are 32, remainder is 0. 4 bond pair, 0 lone pair. While we are adding VSCP equal to 4. VSCP 4 means sp3. This is sp3 hybridization. What hybridization? sp3. What about PCl6 minus? PCl6 minus means here valence electron. See, PCl6 minus means valence electron of phosphorus is 5. Chlorine is 7. 7 into 6. Minus 1 means 1 electron is added. So 5 plus 6 into 7 means 42. Plus 1. That means total 48. 48 divided by 8 if I am doing means bond pair equal to 6. Lone pair equal to 0. VSCP equal to 6. That means which hybridization? sp3d2. So this is sp3d2. sp3d2. In solid structure they are existing like that. sp3 and sp3d2. So what's the change? sp3d2, sp3 and sp3d2. Option A is the correct answer. What's the correct answer? Option A is the correct answer. Is it okay? Yes. We can move to the next question. What's the question here? The bonds present in N2O5 are. N2O5 means its structure is like this. N double bond O and coordinate bond O. Here 1 electron. 1 odd electron. Here again another NO2. Double bond O, coordinate bond O. This is the structure of NO2. NO2. 2 NO2, in between that 1 oxygen is coming. This is the structure of N2O5. Here you can see this is a coordinate bond. Or else it is called dative bond. These all are covalent. This is covalent. This is dative. So which all are the bonds are present here? Covalent and dative. So answer is D. Ready? So the next question is decreasing order of stability of N2, N2 minus, N2 plus is. So we know the idea, we know how to calculate the bond order. N2 means total 14 electrons are there. According to our idea, 14 electron means bond order is 3. Okay. Then N2 minus means that contain 15 electron is there. Its bond order will be 0.5 less than this one, 2.5. Okay. And N2 plus means that is also 13 electron less than 0.5 less than 3. That means that also 2.5. So anyhow, out of this, the most stable one is N2. They are asking about the stability. Most stable one is N2. Then this is N2 minus, this is N2 plus. Now their question, both have same bond order, which one is more stable? Listen to me very carefully. N2, I will write the electronic configuration of N2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, okay, pi 2p x2 equal to pi 2p y2, then sigma 2p z1. This actually N2 plus. This N2 plus last electron is in bonding molecular orbital. This N2 minus means that will be sigma 2p z2, then pi star 2p x1. That is an anti-bonding molecular orbital. So the electron present in bonding molecular orbital have low energy. So that's why that will be more stable even though both have same bond order. So after N2 plus will come. After that which one will come? N2 minus will come. So answer is N2, then N2 plus, then N2 minus. So option C is the correct answer. Even though both of them have same bond order, but N2 plus last electron is in sigma orbital. N2 minus last electron is in sigma star, not sigma star, pi star orbital, anti-bonding. Okay, that idea you have to keep it in mind. Yeah. Next question, this is the next question. Which all are paramagnetic? I already told you, paramagnetic means odd number electron plus 16 and 10. Electrons containing molecules are paramagnetic. Here O2 means 16 electron, paramagnetic. What about O2 minus? O2 minus means 17 electron, paramagnetic. And N2 means 14 electron, diamagnetic. What about N2 plus? N2 plus means 13 electron, paramagnetic. So A, B and D. So A, B and D will be paramagnetic. Idea clear? Ready? We can move to the next question. What about the question here? The correct order of increasing carbon-oxygen bond strength of carbon monoxide, CO3 2 minus, CO2 is. So we know the structure of carbon monoxide. Carbon monoxide means around the carbon 4 electrons are there. Here oxygen is there. Around it 2, 4, 6. So they will make a double bond, as well as oxygen will donate 2 electron because of coordinate bond, and here 2 more electron will be there. This is the structure. So oxygen charge will be, formal charge will be plus, carbon formal charge will be negative. Anyhow, this is the structure. Here carbon oxygen bond order equal to how much? Bond order equal to 3. And what about the case of CO3 2 minus? CO3 2 minus means its structure is like this. CO3 2 minus. Okay, its structure is like this. Here what we can do? We have to find out the bond order. Here you know resonance is there. So the bond order is equal to what? 1 plus number of pi bond is 1. 1 divided by in between carbon and oxygen, 3 sigma bonds are there. So 1.33 is the bond order. In the case of carbon dioxide, its structure is C double bond O and double bond O. Linear structure, bond order is fixed. It is 2. Now you tell me which is having bond. They are asking carbon oxygen bond strength. Bond strength is directly proportional to bond order. Which is having more bond order? Carbon monoxide. Carbon monoxide is having more bond strength. Then carbon dioxide. Then CO3 2 minus. CO3 2 minus will come. So answer is what? Option A is the correct answer. Ready guys? Yeah. So you must have to know the structures and all. You have to practice. Then it will be easy. Yeah. We can go to the next question. Which is most viscous? Which is most viscous? The one which can form more intermolecular hydrogen bonding will be more viscous. Here you can see only one OH, here only one OH, here 2 OH are there. So it can form more number of intermolecular hydrogen bonding. So it is difficult to move. So more friction will be there. So automatically it is most viscous. Okay, ready? Yes. Next one. What about the next question? Which of the following is the correct regarding boiling points? We know fluorine, chlorine, bromine, iodine. This all belongs to 17th group. They are forming hydrates are HF, HCl, HBr, HI. Once we are going downside, their halogen size is increasing. So mass is increasing, boiling point will increase. So we are expecting the order HF first, then HF is having least boiling point, then HCl, then HBr, then HI. But there is one problem. In the case of HF molecule, they can form what? Intermolecular hydrogen bonding. That's why it will come here. So HF is having more boiling point. Here it will come. So HCl, then HBr, then HI. Here only which one will come? HF. Because of the most powerful intermolecular hydrogen bonding is with hydrogen is forming with fluorine. So that's why HF have more boiling point. More intermolecular hydrogen bonding means more boiling point. Okay. So HF, then HI, then HBr, then HCl. Option C will come. Ready guys? You got it? Yes. We can move to the next question. What's the question here? H2O is polar, whereas BeF2 is not. Only because of its structure. See, H2O is this one. This is H2O. 2 lone pairs are there. See, here this oxygen is electronegative. That will withdraw the electron towards it. Dipole moment is in this direction. Here dipole moment is in this direction. Then atomic dipoles are there. Anyhow, all the vectors are, its resultant will be in this direction. So they have some dipole moment. So that's why they are polar. What about BeF2? BeF2 is linear. BeF2 is linear. This fluorine is electronegative. That will withdraw the electron towards it. Dipole moment is towards the fluorine. Here also towards the fluorine. 2 equal and opposite dipoles. 2 equal and opposite forces, vectors are like this. So they will get cancel. So mu equal to 0. Mu resultant equal to 0. That is non-polar. So what's the answer? Why it is H2O is polar whereas BeF2 is not? Because H2O is angular and BeF2 is what? Linear. H2O is angular, BeF2 is linear. Ready? We can go to the next question. What's the question? In which of the following shape is same? Hybridization is different. We can check the first option. ICl2 minus and HCF2. we have to find out the total number of valence electron. That's enough for us. Okay, iodine valence electron 7, chlorine 2 into 7, and minus 1 means we have to add 1 electron. So 7 plus 14 plus 1, that means 22 valence electrons are there in ICl2 minus. They are linear shape. 2 bond, because divide with 8 means 2 bond pair, 3 lone pair. Okay, what about XCF2? That also linear, we know. Here valence electron is 8, then here 2 into 7. So 8 plus 14, that also 22 is coming. Both have same shape, same hybridization, because total number of valence electron is same means same shape, same hybridization. Okay, next, what about the next one? SO2 NO2 plus. See, SO2 means sulfur valence electron is 6, oxygen valence electron is 2 into 6. So that means total 18. 18 divided by 8 means 2 bond pair, 16. Then remainder is 2 means 1 lone pair. So that means angular shape. What about the hybridization? Bond pair plus lone pair you have to add. So total 3. 3 means sp2 hybridization. What about NO2 plus? NO2 plus we already did. Nitrogen valence electron is 5. Oxygen is 6 into 2 plus means minus 1. So total 16 valence electrons are there. 5 plus 12, 17 minus 1, 16. 16 valence electron means 2 bond pair, 0 lone pair. So hybridization is sp linear shape. Shape is not same. Hybridization also different. What about the third one? See, SO2 and NH2 minus. NH2 minus. Here sulfur valence electron is 6. Oxygen also 6 into 2. That we already did. That is 18. 18 means what? That means 18 means 18 divided by 8 means bond pair equal to 2, lone pair equal to 1. So angular shape, hybridization sp2. What about NH2 minus? Once we are taking NH2 minus, don't forget hydrogen valence electron, you have to take it as 7, not 1. If you are using my formula, I mean total valence electron by 8 if you are using it, that's my formula. If you are using that one means you have to use hydrogen is 7. Okay, then only, because I am dividing that one with 8 because they are all obeying octet rule, but hydrogen is not obeying octet rule. So if you are using that formula means you have to take it as 7. They are just behaving like what? Halogen. That's the concept. Okay, so IUPAC don't know, we are using that one for us as a shortcut. Okay, yeah, here see, nitrogen is what? Nitrogen valence electron is 5 plus hydrogen valence electron is how much? Hydrogen is 7, I will take into 2. This is minus 1 means 1 electron I have to add. So that means 5 plus 7 into 2, 14 plus 1, that means 20 I will get. 20 divided by 8 means 2 8s are 16, remainder is 4. So 2 bond pair, this also I can make it as pair, 2 lone pair. 2 bond pair, lone pair means its hybridization is sp3 because VSCP is 4. What about the shape? Angular. So both have same shape. But hybridization is different. So what's our answer? Our answer is C. Ready guys? Yeah. If you know my formula, total valence electron by 8, then you can solve it guys. What about the next question? Question number 28. Yes, again with the same concept. ICl5 and ICl4 minus, the correct statement. What about ICl5? ICl5 means how we will find out? Iodine valence electron is 7 because it is 17th group. Chlorine valence electron is 7, 17th group. Like that 5 chlorine are there. So 5 into 7, 35. 35 plus 7, 42. Okay, 42. 42 divided by 8. 8 means 5 8s are 40. Remainder is 2. I already told you what? This is bond pair. This one we have to make it as pair, 1 lone pair. 5 bond pair, 1 lone pair means that is nothing. That is square pyramidal, not bipyramidal because 1 is lone pair. Square pyramidal. So ICl5 is square pyramidal. Okay, ICl5 is square pyramidal. And what about ICl4 minus? ICl4 minus. See, ICl4 minus means iodine valence electron is 7. Chlorine valence electron also 7, but 4 chlorine are there. Okay, into 4. Minus 1 means 1 electron they are adding, plus 1. So 7 plus 4 into 7 means 28 plus 1. So 28 plus 7, 35 plus 1, 36. 36 divided by 8 once you are doing, 4 8s are 32. 4 8s are what? 32. Remainder is 4. 4 bond pair, and 4 is the remainder that you have to make it as pair. 2 lone pair, that means 4 bond pair, 2 lone pair means square planar according to VSCP. ICL4 minus is square planar, option C. We did 28th top most repeatedly asking concepts from chemical bonding. Next one, question number 29. 2 pi bonds and half sigma bonds are present in. 2 pi bond, half sigma bond means bond order is 2.5. Bond order is 2.5. That is present in which one? That's the question. Here you can see O2 plus means how many electron? 15 electron. 15 electron means bond order is 2.5. N2 means total 14 electron, bond order is 3. That's not our answer. What about oxygen? Oxygen means total 16 electron, bond order is 2. That is not our answer. What about N2 plus? N2 plus means total 13 electron, bond order 2.5. So our answer is either D or A. Out of that, which is the correct one? Both have bond order 2.5. What about the first one? 2 pi bond and half sigma bonds. 2 pi bond and half sigma bonds. Here how many electron? How many electron? 13 electron. We can write for that 13 electron N2 plus while we are writing. You can see sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p x2 equal to pi 2p y2, pi 2p y2, sigma 2p z1. This is actually 13. Here half sigma bond. And how many pi bond? 2 pi bond. So answer is what? D is the correct answer. You can check for A. It is not possible. They are not obeying this idea. Ready? So answer is what? D. N2 plus. Yes. We are going to the next question, the last question. This one already I asked you to comment in the comment box. Okay, that you have to comment it. CO3 2 minus bond order in that carbon oxygen bond order. Answer. Okay. Answer is what? That you have to comment it in the comment box. We did 29 question, and this one we already did. We already went through that question. Once you are watching the video, you can see the answer for that one, and you have to comment it, guys. Hope you enjoyed the video. For more video, subscribe Brilliant Katha. See you again in next video. Up to that, thank you guys.